In this lecture, we're going to show the different types of finite elements that we can use in the static simulation. So based on the geometry of our model, we can choose a different finite elements. We can choose a solid finite elements that we used in the previous chapter, and those are 3D finite elements. We can use a shell finite elements, and those are 2D elements, and we can use a beam finite elements, and those are 1D elements. So with solid finite elements, we can create a solid mesh. This solid mesh is appropriate for bulky objects. So the program creates a solid mesh with tetrahedral 3D elements. And those elements can be linear or parabolic finite elements. As we saw in the previous chapter that we had a 3D tetrahedral finite elements. When we have a shell elements or 2D elements, then we got a shell mesh. The shell mesh has uniform thickness, and that can be applied to surface or sheet metal. So we can use a shell mesh when we have a surface or sheet metal model. And when we have a surface, the user has to define the thickness of the shell mesh. And when we have a sheet metal, then the thickness is extracted from the thickness of the sheet metal. So the program automatically defines the thickness of the shell mesh. And in the next chapter, we're going to look at a shell mesh on the surface and on the sheet metal, and we're going to get more into detail. And the third option that we have is a beam mesh. We got a beam mesh when we use a beam element, or this is 1D element. And this is a line element defined by two endpoints and a cross section. And those endpoints are joints. So those elements can be truss and beam 1D finite elements. And the fourth option that we have is a mixed mesh. So when we have a different geometries, then the program automatically uses a mixed mesh. So there is possible combination of the shell, beam, and solid mesh. Now, why is it important to have a different types of mesh? Well, based on the geometry of the model and based on the type of the mesh, we can get a different results. And depends what is the aim of our analysis, we have to choose appropriate mesh that will get the most accurate results.